Hello viewers, welcome to JSM. In this lecture, we are going to discuss EAMCET previous year solutions. So chapter is redox reactions and 2022 questions we are going to discuss. So first one, which of the following are disproportionation reactions? What is a disproportionation reaction? The reaction in which same element undergoes both oxidation as well as reduction, they are called as disproportionation reactions. Okay, so let us see here. So to identify, we have to assign the oxidation states, right? So here chlorine in the elemental state, oxidation state is 0. Okay, and here sodium +1, oxygen -2, hydrogen +1. See, if you don't know how to assign the oxidation states, I have explained in one video. I will give the link in the description. If you don't know how to assign, you can go through that video once. That is very useful. Okay, so next here, see, sodium +1, chlorine -1, +1, -2, chlorine +1. Here +1, -2. See here, chlorine here from 0 to -1 means it is undergoing a reduction because oxidation state decreased from 0 to -1. Next here, +1 oxidation state, 0 to +1 means oxidation state is increased. So here undergoing oxidation. So same element undergoing both reduction and oxidation in a same reaction. So that's why it is a disproportionation reaction. Next see here hydrogen peroxide, hydrogen +1, oxygen. In the peroxide, oxidation state is -1. So here hydrogen +1, it is -2. Here in the elemental state 0. See, -1 to -2 oxidation state is decreased, so reduction. -1 to 0 oxidation state is increased, so oxidation. So oxygen here undergoing both reduction as well as oxidation, so that's why it is also a disproportionation reaction. Next here KMnO4, potassium +1, manganese oxidation state is +7, oxygen -2. So here potassium +1, manganese +6, -2, and here manganese +4, -2, 0. Okay, see here potassium oxidation state remains same on both sides, and manganese +7 to +6 and +4. In both the cases, both the compounds oxidation state decreased, means it is only undergoing reduction, not oxidation. And oxygen -2 to, and here also -2, 0. So in this case oxidation state is same in two molecules, and in one case oxidation state increased means undergoing oxidation but not reduction. So that's why it is not a disproportionation reaction. And see here 3MnO4 2-. See here oxidation state of manganese is +6 and hydrogen +1 only, and manganese here +7 and here +4, oxygen is -2, +1, -2. See now here manganese +6 to +7 means it is undergoing oxidation. +6 to +4 means it is undergoing reduction. So that's why it is also a disproportionation reaction. See here A, B and D. So option B is the correct answer. Okay, see, so many times questions were asked related to this one. In the previous year 2021 also I have explained there are many questions asked related to this. Next, the number of moles of ferrous oxalate oxidized by 1 mole of KMnO4 in acidic medium is. Okay, so here the reaction between potassium permanganate and ferrous oxalate. Similar reaction already I have explained in the 2021 also in the previous video. Okay, see here KMnO4, ferrous oxalate. Okay, we focus on these two, forget about all this because they asked how many number of moles of ferrous oxalate is oxidized by 1 mole of KMnO4. Okay, see here for 6 moles or 6 moles of KMnO4 is oxidizing how many moles of ferrous oxalate? 10 moles of ferrous oxalate, and they asked per mole. So that's why for 1 mole of KMnO4 how many moles is oxidized? 10/6. So no, for 6 moles 10 moles according to the balanced equation. For 1 mole how many moles? 10/6. So that is nothing but 5/3 moles. Okay, so per mole of KMnO4 that can oxidize 5 by 3 moles of ferrous oxalate. So option D is the correct answer. Okay. Next, identify the values of A, B, C, D and E for the following unbalanced reaction. So here this is the unbalanced reaction and they have given the stoichiometric coefficients of each and every reactant and product. Okay, see, very simple in this type of questions if you find in the exam. So first focus on the other than oxygen and hydrogen. Okay, see here we have other than oxygen and hydrogen, if you see potassium and nitrogen and here carbon. And next, see, remember these, very easy this one. Okay, so other than oxygen and hydrogen first focus, and then see here we have 3 different elements. In that this carbon is found in 2 different products, so that's why keep that one also side. Next, see, potassium and nitrogen we have. See here in this molecule only potassium and nitrogen is present, and here one nitrogen, one potassium is present in one KNO3 molecule, and here what is the product? Dinitrogen is formed, and here in the potassium carbonate K2CO3. Okay, so here for definitely here we should take the double the number of moles when compared to these 2 molecules. Yes or no? Here in one molecule 2 nitrogens, here in one molecule 1 nitrogen. Similarly here in one molecule 1 potassium, here in one molecule 2 potassium. So that's why here our option D is the answer. Very simple. See here, this is 48 and B. What is B? Number of moles of dinitrogen. So that is 24. Okay, see, 48, 24 into 2, how many? 48 nitrogen. So here 48 nitrogen, this side also 48 nitrogens. Remaining all will be definitely balanced. In the similarly, you can check for all the elements also. Okay, clear? So remember these steps and then easily you can solve this type of questions. Next, identify the pair of reactions undergoing a disproportionation from the following. See, it's very similar. Already we discussed the first question also. See here, this already we discussed. This is a disproportionation reaction. The first question already I explained. And see this one, this is also a disproportionation. So these 2 are disproportionation reactions. Okay, 2 are disproportionation reactions. And see here, if you consider these 2 all the reactions, you can easily check. Okay, so I don't want to waste your time. Already you know what is a disproportionation reaction. We discussed and we did one question also. Okay, so similarly you can check these are in all these pairs only one reaction is a disproportionation, other one is not a disproportionation. But here we have to identify the pair of reactions undergoing disproportionation. So here both the reactions undergoing disproportionation. What is the oxidation state of sulphur in the sulphur containing product of the following reaction? So here one reaction is given. So here we get SO4 2 minus plus Br minus plus H plus. Okay, so this is the reaction. No need to balance this one also. Just they ask you to find what is the oxidation state of sulphur in the product. Okay, so here this is the product. What is the oxidation state of sulphur here? +6. Okay, so option A is the correct answer. Okay, so here oxidation state of sulphur is +6. What are the oxidation states of 3 bromine atoms in Br₃O8 molecule? Okay, so here first let us write the structure. Next, what are the oxidation states of 3 bromine atoms in Br₃O8 molecule? Okay, so first let us write the structure, then we get the oxidation states. So we have 3 bromine atoms. So here this bromine attached to 3 oxygens with a double bond, and this bromine is also attached to 3 oxygens, and this bromine attached to 2 oxygens. Okay, so here now oxygen carries -2 charge. So this bromine is in +6 oxidation state. Similarly, here also -2, -2, -2, +6. See, I have explained all these molecules in one video, which are very, very important molecules. Mostly in any entrance exam, from those molecules only we get the questions. Okay, so if you are interested, please go through that video. I will give the link in the description. So here -2, -2. So this bromine has +4 oxidation state. Okay, so +6, +4, +6. So option B is the correct answer. Next, match the following. So here 4 different options are given and here reactions are given. We have to match. First one, combination reaction. Okay, what is a combination reaction? A reaction in which 2 or more species combine to form another product. Okay, so in this case, definitely one of the reacting species must be in the elemental state. So let us see. So these two are the different molecules. So this is not a combination reaction. And here only one species is here. See here, magnesium and nitrogen both are in the elemental state, and so combination reaction is this one. Okay, for A, what is the correct matching? This one, third one. Next, decomposition. What is a decomposition? Opposite to combination. One molecule dissociate to give 2 or more species. So this is, see, KClO3 is giving KCl plus O2. So that's why, what is the decomposition reaction? This one, fourth one. Next, disproportionation reaction. See, this is a disproportionation reaction. We have discussed 2 questions just now. 0 to -1, 0 to +5. Okay, so that's why it is a disproportionation. And a displacement reaction. See here, what is happened? Silver nitrate, and here we have silver chloride. Here we have calcium chloride, and the product here is calcium nitrate. See here, silver is Ag plus is substituted or displaced by the calcium +2, and here calcium is displaced by the silver. Okay, so that's why here for displacement reaction this is the correct matching, and here, so for A 3, for B 4, for C 2, for D 1. So option D is the correct answer. Okay. Next, which of the following reaction is not a disproportionation reaction? See here, calcium +2, carbon is in +4 oxidation state, oxygen -2. Calcium here +2, oxygen -2. Carbon here +4, oxygen -2. So here calcium here +2, +2, oxygen -2, -2, carbon +4, +4. So here none of the element is undergoing either oxidation or reduction. So that's why it is not a disproportionation reaction. So option A is the correct answer. Here similarly, see, this already we discussed. Okay, this reaction also already we discussed. See this, copper +1 to +2 oxidation, +1 to 0 reduction. So this is also a disproportionation. Next, which of the following is not a disproportionation reaction? So here, first one, mercurous chloride. Here mercury is in +1 oxidation state, chlorine -1, 0, here +2, here -1. Okay, see here, mercury is going +1 to 0 reduction, +1 to +2 oxidation. So it is a disproportionation reaction. Next here, phosphorus, H3PO3, oxidation state of phosphorus is +3. And here H3PO4, oxidation state of phosphorus is +5. And here oxidation state of phosphorus is -3 in the phosphine. So +3 to +5 oxidation, +3 to -3 reduction. So it is also a disproportionation. Next here, 0. So +1, -1, +1. So 0 to +1 and 0 to -1. So it is also a disproportionation reaction. Already we discussed this. Next, see this. +2, -2. +1, sulphur +6, oxygen -2. Barium +2, sulphur +6, oxygen -2. +1, -1. See here, barium oxidation state remains the same, sulphur oxidation state also remains the same on both sides, and oxygen -2 to here -2 and here -1 means here few oxygens undergoing reduction, oxidation, -2 to -1 oxidation, but no reduction. So that's why it is not a disproportionation reaction. Option D is correct. Next, among phosphorus, sulphur and nitrogen, the elements which undergo disproportionation when heated with NaOH solution. So here generally this dinitrogen do not react with sodium hydroxide, only phosphorus and sulphur react with sodium hydroxide, and see these are the reactions. Okay, see here when phosphorus react with sodium hydroxide we get these two products, and it's in the elemental state 0 oxidation state, and here -3 and here +1. Okay, see here 0 to -3, 0 to +1, it is a disproportionation. Next here sulphur 0, and here the average oxidation state is +2. Actually here two sulphurs, one sulphur is in -2 oxidation state, another second sulphur. Okay, first sulphur is in -2 and second sulphur is in +6 oxidation state. If you take the average oxidation state, that is +2. This also already I explained in that video. And here sulphur is in -2 oxidation state. So 0 to +2 and 0 to -2. Okay, so oxidation and reduction. So that's why phosphorus and sulphur only undergoes disproportionation when heated with sodium hydroxide. Actually dinitrogen do not react with sodium hydroxide generally. Okay, so thank you for watching. In the next video we will discuss another chapter. Thank you.